All right, hi everyone. This video is going to look at the Cartesian plane and slope as a rate of change. So the learning goals for this video are to link rate of change with the steepness of a line and to calculate the slope of a line given a graph. So we're just going to go over an example of a graph from a real world kind of a context. So the graph shows the relationship between the cost of a plumber and time worked. What is the rate of change in cost? So basically, I want to know how much this plumber charges every hour. So remember, one way that we can do that is we can find 2 points along this graph, and we're going to then find the rise over run, right? So I'm just going to write that down, rise over run. So I can pick this beginning point here and here, this point right here. I can create a little triangle here, and then I can just identify what the rise and the run are. So the rise is the difference in the cost, right, from here to here. So this is at 100, and then this is at 160. So there's a difference of $60 here. And I can also tell because each square here is worth $20 because 2 squares are worth 40. So the rise here is $60. Now the run here is 2 hours because this is at 0 and then now it's at 2 hours. So that length is 2. So I'm going to divide it by 2 hours. So if I divide it, I get $30 per hour. Okay, so that's how we can find rate of change in cost, and that's one way. Another way that we could is, remember, we can pick 2 points and do a little bit of subtraction. So let's pick 2 other points here. Let's pick that one and this one over here. We identify the coordinates. So this is above 4 and beside 220. So this is, I'm going to write 4 comma 220. And this one is under 6 and next to 280. So I can write 6 comma 280. Now we could also calculate this, remember, by subtraction, right? So I'm going to do 280 minus 220. Minus 220, and then I can do 6 take away 4. 6 take away 4. Notice that when we subtract, we end up with 60 divided by 2, which is exactly what we have over there. And so the rate of change is also going to be $30 per hour. So it doesn't matter how you do it. Those are the 2 different ways that you can calculate rate of change from a graph. So we're going to move from real world situations to a more abstract plane. So this is called the Cartesian plane. So you notice that there are 2 axes here, just like what we have before. We have an x-axis, which is the horizontal, and then the up and down vertical is the y-axis. The difference between this plane and the plane before is now we're clearly seeing negative values here. So this is the origin over here, like the middle of this axis. Now the origin, that point is 0, 0. Now anything to the left of the origin here on the x-axis is negative, and anything below the origin on the y-axis here is also negative. A couple terms that we need to highlight is this point here, that the graph crosses the y-axis. We used to call that the initial value, right? But now you notice this line actually goes on forever and ever, so there's no initial value, right? It doesn't start there. Okay? But that point there, that's called the y-intercept. And it's called the y-intercept because that's where this line intercepts or crosses the y-axis. This point over here, where the line crosses the x-axis, well, that's called the x-intercept. So those are going to be important points that we need to know, and the terms that need to be known as we're playing more with the Cartesian plane. So we're going to learn how to calculate the slope of a line. So basically how steep a line is represents how quickly y changes with x. So if a line is kind of relatively flat like this, it has a lower slope or a smaller slope compared to if a line was really steep. Okay, so how steep the line is called its slope, and we can calculate it exactly in the same way as how we calculate the rate of change from the graph that we just started with. So let's pick any 2 points. So if this is ever there, I always like to pick that one, the y-intercept, and some other point, let's say this one right here. So I'm going to identify those 2 points. This one here is at 0 and up to 1. So I'm going to write 0 and 1. This point here is above 3 and next to 3. So I'm going to write 3 and 3. So what I'm going to do is to find the slope, we're going to, again, just subtract the 2 y numbers, okay, the one from each point, so 3 minus 1. And then I'm going to write 3 minus 0, so I'm going to subtract the x numbers. So 3 take away 1 is 2, and 3 take away 0 is 3. So we have 2/3. Now we can leave this as a fraction. Instead of dividing it and turning it into a sloppy decimal, it's just best to leave fractional values as a fraction. All right, so that's basically how steep this line is. It has a slope of 2/3. Now you can also, just like what we did before, you can look at these 2 points and see what the rise and the run are. All right, so between these 2 points, I can draw up that triangle, and I can see that this has a rise of 2 and a run of 3. Okay, so you could also just look at the graph and see 2/3. All right, now I just want to show you the general form or the formula for slope. Now, you don't need to remember the formula if you know and understand what you're doing. Okay, but a lot of textbooks and maybe in future learning, you might come across a formula. So I just want you to be familiar with that. So for any 2 points, let's say the first point is some value of x, so we're going to call it x1, and some value y, y1. And another point, which is x2 and y2. So remember, what we can do is we just subtract the 2 y values. So slope, now slope, they give a letter, okay? We call it m. M for slope, makes a lot of sense. Remember, what we do is we're going to subtract the 2 y numbers. So I'm going to do y2 take away y1 divided by, and then I'm going to subtract the 2 x numbers. x2 take away x1. This is the general formula for slope. So a really efficient way to calculate slope is to know what the coordinates are for 2 points, do the y subtractions and do the x subtractions, and then you divide. So let's go through some examples together. So we're going to calculate the slope of the given lines, and let's choose 2 points. So any 2 points. So let's pick that one. So this is at 0, comma, -2. So I'm going to write 0, comma, -2 here. And let's pick, oh, it doesn't matter. Okay, let's pick this one right here. Okay, so this is at 2, comma, -3. Okay, so remember, the x number goes first, and then the y number goes second. All right, so remember, now we're going to calculate slope by subtracting the 2 y numbers. Okay, so I can write -3 subtract -2. So to separate those minus signs, I'm going to write -2 in a bracket. Divided by, and then we do 2 take away 0. So what's going on over there? So -3 take away -2, that's going to be -1. Now if you're not sure how to do that, you can always just double check with a calculator. And then I'm going to write 2 take away 0 is 2. So slope is -1 over 2. Some people put the negative right in the middle there, so you can do that as well. Okay, so the slope of this line, m, is -1/2. You can also see it here. Remember, if you can create a triangle. So the rise here, because you have to go down, that's why the rise is negative. So you have to go down and then over 2. So that's why it's -1 over 2. Now the line is going downwards, right? So when the line is going downwards, the slope is going to be negative. So that's a really important point, okay? Downward line means it's going to have a negative slope. All right, let's do another example. So we're going to calculate the slope by picking 2 points. So let's change it up. We'll pick that point there. So that is at 1, 3. So I'm going to write 1, 3. And let's pick this point over here. So this is at 4. Remember, we read the x point first. So 4, 3. So now we're going to calculate the slope, which is, let's first subtract the 2 y numbers here. So that's 3 minus 3. And then we're going to subtract the x numbers. That's 4 take away 1. So 3 take away 3 is 0. 4 take away 1 is 3. 0 divided by 3, anything, or 0 divided by anything is just 0. So the slope here is 0. Now, that means that there's no slope. And that's true of this line if you think about it. This is a perfectly flat line. So it's not slanted in any way. It's not steep. So that's why there is no slope, or the slope is 0. Okay, so any horizontal line, the slope is 0. Okay, so for a horizontal line, slope is equal to 0. That's true of all horizontal lines. Let's do one more example here. We've got a vertical line. So let's pick 2 points and calculate the slope. So we've got here a point, let's pick that one. So that is at 3, 1. So I'm going to write 3, 1. And let's pick this point right here. And that is at 3, 4. Now, let's calculate the slope. So again, we subtract the 2 y numbers here, 4 and the 1. So 4 minus 1. And then we do 3 minus 3. So the 0 now is on the bottom. So 4 take away 1, though, is 3. And then 3 take away 3 is 0. When you do 3 divided by 0, though, on a calculator, I invite you to try that out. It should tell you that there's an error or it's undefined, and you cannot divide any number by 0. So because there's no number to describe that, we say that the slope here is undefined. Okay? Basically, this thing is so steep that we don't have a number to describe it. So any vertical line means it has a slope that is undefined. So I hope that this walkthrough has clarified how you can calculate the slope of any line by picking 2 points. So good luck with all of your slope calculations. All the best.